Now on to graphing hyperbolas by hand. We're going to look at the equation in general form, and we're going to determine our A and our B and our center and use the idea to help us get an accurate graph for this hyperbola. So I left the steps here. You'll notice in the top part, we did a previous example and I was talking about this center sort of rectangle or center box. I can emphasize that a little bit more to help us out. So we're going to look at the equation. It looks like to me, I already noticed it's a hyperbola equation based on the minus sign that's separating the squared terms. I also can tell, because the x term comes first, that we have ourselves a horizontal hyperbola. So that means what's going to happen is your hyperbola branches are going to open up left and open up right. So you can have a visual just to start off with. It also gives us a heads up of how we're naming our A and our B. So if this is the horizontal hyperbola equation, remember that that would lead us with the a square being associated with the positive term. So we have a square equaling 36. So that's going to lead us with a being 6. And b square is associated with the negative term, so that's going to be 64, which leaves us with b equals 8. So some nice perfect squares here. Also note to ourselves that we don't see an x minus or x plus or y minus or y plus. So right away our center is at our origin. So we can already label that already. So I might as well draw that in. And now what's interesting with this is we're going to draw our box before we draw anything else. So the A and the B tell you the directions, and I always like to look at what the A term is underneath, and that tells me what direction I should be counting out from the center. So you notice that the A equals 6, that's 6 units out from the center, and because that's associated with the x squared term, I'll be counting out left and right. So I'm going to go 6 units to the left. 1, 2, 3, 4, 5, 6. 6 units to the right. 1, 2, 3, 4, 5, 6. And that, by the way, gives you the vertices of the hyperbola. If you'd like, you can label them now, or we can always label them later. But while we're here, might as well just count to get here. So the vertices would be -6, 0. And 6, 0. So notice I didn't really refer to my formulas. I'm just looking at what the orientation is. So I'll get back to that. But we already kind of addressed it. The next thing I'd like to do is find how tall this center rectangle will be. So I'm going to count B units up and down because the B is associated with the Y term. So 8 units up. 1, 2, 3, 4, 5, 6, 7, 8. You have to see me visually mark it. I apologize. And down. 1, 2, 3, 4, 5, 6, 7, 8. Sometimes with all the grids, my eyes skip a square, so I have to be careful with that. So color code helps. So after drawing these guide points, what's happening is we will draw our box, or sometimes we call it the rectangle too. And basically, you're just going to draw a dashed line as tall as the highest point and as wide as the vertices in this case. The little dashed box to help us. Realizing it's not really part of the graph, but super important because it kind of determines how wide or narrow your branches are. So here we have our box. We also, from our box, we have our asymptotes. So remember, all you have to do is draw a line connecting each corner through the center. So I exaggerate. Usually it's nicer if you have a straight edge, but I'm not doing so bad here. Guess I'm not shaky yet. So we do have our asymptotes that are drawn, and we can get back to naming them. But really what I want to do is draw my hyperbola. And what that would entail is understanding, well, where should we draw them? Well, they have to be on the x-axis or parallel to the x-axis if we're off center. But this means we make our branches really, really wide because you always want to hug your asymptotes. So you notice we have our two branches. So yes, we do go off the graph a lot of times. So that is the graph. You don't really need a lot of information besides what the A and the B and the center are to get that graph, but naming the other important parts will be useful. We do have the vertices. While we're here, we could talk about the foci. That really has nothing to do with the graph in the sense of what we're using as a hand-drawn graph, but we needed the foci in the first place to be able to draw the hyperbola. Something we can't really demonstrate right here. But remember, the foci is given by a formula. C equals square root of a squared plus b squared. You guys notice how similar it is to an ellipse, except that the sign is plus this time. So notice it's kind of switched based on the hyperbola equation has a minus in it, but the foci formula has a plus, and then when it's an ellipse, it's the other way around. So what we do is we just plug in our a square and b square. And a square is 36. B square is 64. Where is that? There we go. And I believe this might be nice because isn't 36 and 64, isn't that 100? Yes. I'm always surprised when we get a perfect square on the inside. So actually square root of 100 right away, we have 10 units. So what does that mean? If you're going to label what they are, you're counting from the center. And remember, your foci, just like as you had with your ellipse, it's on the same axis as your vertices. So your foci or focus points, you would just count outwards from the center 10 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You end up being on the edge. I'll label that with an F. And the same thing here. I believe it's symmetric, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we have our focus points or foci. And like I said, you can either use the formula sheet or you can just count from the origin. You'll notice that they are, in a sense, they intercept the x-axis. So we have a negative 10, 0 and positive 10, 0. So just by counting, just got to know how to find C and its relationship. So you got the foci. Last thing is asymptote equations. That you can find just by kind of viewing what type of equation you had. And I'll kind of emphasize, remember it has to do with A over B. So asymptotes. Usually we're in the form y equals mx plus b, right? But just to kind of develop this with you, when you are centered at the origin, that means your y-intercept is 0. So you really have mx plus 0, but whenever you're adding 0, you never write it. Now, to develop this further, remember that your asymptotes, there's two of them. There's one with a positive slope, rising from left to right, and there's one with a negative slope. So the positive slope, you can kind of see there, and then the negative slope, you can see right here. So we don't have to even worry about it. We just use a plus or minus to account for that. And now if you really want to understand slope, remember slope is rise over run. So if we're dealing with rise over run, we're just going to talk to ourselves and say, well, if we have 2 points, I'm going to look at the center and an edge of the box, little corner of the box. And if I want to talk about rise over run, I'm going to look at how far am I going up? Maybe I'll highlight that with pink. Well, it's a little harder. There we go. And it has to do with your, in this case, it has to do with the edge of your box. That's a B coordinate. So that's, sometimes it helps you. That's 8 units. So instead of M, that's 8 units. And then if you're running you'd be saying, how do I get to the corner of the box? I gotta move this way. So that has to do with your A term. So that's 8 over 6. So normally, I mean, this is correct, but you probably would reduce it if it's possible. 8 over 6 gives us, let's see, 2 goes into 8 4 times, 2 goes into 6 3 times, 4 over 3x. So those are the equations of your asymptotes. So if we were looking at the formula sheet, they would then say, okay, if it's a horizontal hyperbola, it's going to be b over a. And it's the same thing, but I always prefer to look at my graph to really help me out. It makes more sense. I see rise over run, making that little slope triangle. Super cool. So I believe we have everything we need based on the directions. So we're good to go on this graph. So take a little time, you practice. You can feel free to play with example 7. You'll notice it's written a little bit differently. We had a little experience with that in the ellipse section, but I'm more interested in example 8. I want to kind of look at it and say, okay, it is in this nice general form. I don't have to do anything special to the equation, but I do know we're off center. We're not centered around the origin anymore. Before I do anything, I may want to determine, well, what is the positive term? Looks like the y squared term is coming first. So right away, heads up, it's telling me that I've got myself a vertical hyperbola. So that means the branches open upwards and downwards. So that also gives me a heads up. Right away, I know that the a squared term is associated with the y squared, the positive term. So a squared is 9, which can automatically help me identify a is 3. And then the b squared term, or b squared, is associated with the x squared. So b squared is 16. That means b is 4. So this is good. We have almost everything we need. Let's identify that center. Be really careful. The center is HK. Remember, X's always come before Y's. So don't be fooled by this, but the X term comes first. So that is -1 for that center. And then the Y term should be +3. So sometimes when it switches on you, you got to look at who's the X term, who's the Y term. Always make sure that the X value goes first, the Y value goes second. So with the center, we can plot it, -1, +3. And then if we're determining, to make our box, we have to determine the A, which is 3. Should we be counting upwards, downwards, or left and right? And as far as we know, we understand that the 9, or the a squared term, is associated with the y. So that's always an up and down movement, rise. So we'll be counting 3 units up to get our vertice, and 3 units down to get our other vertice. Now right away, if you'd like to, because we're already on a roll, you can name what those ordered pairs are. And I do this by counting from the origin. So that's -1, 1, 2, 3, 4, 5, 6. -1, 6. And then the other one is -1 and 0. We don't move up or down. It happens to be located on the x-axis. So we got the vertices already, good to go. Let's figure out how wide to make our box. That is 4 units out from the center. And then because that b squared term is under the x term, that kind of movement is left and right. So from the center, we're counting 4 units to the right and 4 units to the left. There's nothing special about those points. It just does help you determine how wide to make the box. So we will make our center rectangle and make dashed lines as wide and as tall as the A and the B. Now with that box, you can draw the asymptotes through the center and each corner. You notice I kind of use a different color than I plan to use with my graph. So at this point, we're almost there. All you have to do is graph your branches of your hyperbola. And remember, because it's a vertical hyperbola, your branches will be opening upwards and downwards, which is why we're drawing them in this orientation. So the graph is good to go. The next thing we want to make sure, we're reading the directions, we're finding everything we need. We find the center. We're good, we found that already. We did find the vertices. Check to see if we can find the foci. So with the foci, remember that formula, C equals square root of a squared plus b squared. So we'll just kind of plug our a squared in. A squared is 9. B squared is 16. And we actually also happen to get another perfect square. So that's square root of 25, which gives us a 5. So it makes it nice for us to plot our foci. So remember with the foci, they're on the same axes as your vertices. So this would be counting upwards and downwards from the center. Now remember, it's from the center and not the origin. So 5 units from this center. Right, Leica? We still got to finish graphing. So 1, 2, 3, 4, 5. That's our first focus point. And then downwards from the center. 1, 2, 3, 4, 5. Now right away, you're going to see me just kind of name what those coordinates are. I don't even bother with the formula. I just count based off what they are from the origin. Yes, I don't bother with the formula, Leica. But we can do that later. We can see that it's verified. So what we're going to do is count from the origin. The first focus point, I'll go with the one on the top. It's -1. And counting upwards, 1, 2, 3, 4, 5, 6, 7, 8. So -1, 8. And count the other one from the origin, -1, -2. Now, if you're interested, you can see how the formula goes into play. I kind of figure since I have a nice whole number, I'll just use the origin to count from there. But if you do have an interesting radical, you could either use the approximation or you could use the formula to get those exact values. Feel free to be flexible, just like we did with the ellipses. So we do have the foci now. Last thing is the asymptote equations. So I do want to point out, because we do have a shifted hyperbola, when you make the asymptote equations, you are going with a point slope form. Okay, so remember point slope form, y minus y1 equals slope times x minus x1. But as we develop this, like I'm just trying to connect this to something I already kind of have down. The x1, y1 actually has to do with h and k. So there's less to memorize here. We have the h always associated with the x, the k associated with the y. And essentially, if you look at your hyperbola equation, you just copy what you see before it's squared. So we should have y minus 3 equals the slope times x, what was the equation? X plus 1. No squares, because we're just talking about equations of lines. Now also remember, when you do asymptote equations, you need 2. That's why we have the plus or minus, positive slope and negative slope. And the only thing we need to do at this point is name the slope in terms of its rise over run. So if you see me going from here, you may see me going from the center to a corner of the box, and you just see me rise from left to right. So a little slope triangle right here, and you're again using your A and your B. So it looks like we have 3 units up, that is our rise, and 4 units as our run, 3 over 4. And I guess if you're looking at the formula sheet, then you would say, what is it, A over B? But counting just does the job. Feel free to leave it in point slope form. If you want to solve it for y, feel free to, but there's really no need to in this class. So hopefully this helps you out. Feel free to try. I think I left you with example, was it example 7 to try on your own, see how it works for you. Practice with your homework, and we'll see you in the next example.